So, very good morning, everyone. The voice is audible. See, can you hear me? See, can you hear my voice?
Yes, sir.
Okay, okay, thank you. So, anyway, good morning, everyone, and welcome to this online artificial intelligence classes. For the last two classes, we are talking about inference management systems or inference mechanisms. And mostly like last week, last class, and this week, starting class, the emphasis is same. But you need to understand like every inference management system has certain rules and certain systems or certain symbols that are accepted. Based on that, we try to apply these rules and try to infer whether whatever question that was asked is right or wrong or something like that. So what is that we have done in the last two classes is the first version of axiomatic system. So the first version of axiomatic system is called as natural reduction system. So today what is that we are trying to do is we are trying to take the session in the same name as axiomatic system version 2. So version 2 is the latest, so whenever people try to have an axiomatic system you need to write version 2. So version 1 that we have discussed yesterday and day before yesterday, it is called as natural reduction system. A natural reduction system is a system where all the operators are applicable. Operators in the terms of R and implication, by implication, all these are valid. So axiomatic system, the first version is called as a natural reduction system where all these are valid and all the rules that we have seen, like we have seen addition rule, uh, we have seen modus tollens, modus ponens, many other rules we have seen. All these are accepted in the first version of axiomatic system. So that is called as the name of that is called as a natural reduction system. So axiomatic inference mechanism that we have studied yesterday and day before yesterday is called as the first version. The version name is natural reduction system. A natural reduction system is a system which will allow all the operators at the same time it will allow all the rules. So second version of axiomatic system is concerned, it will allow only one symbol called as implication. It will not allow or, it will not allow and, it will not allow this bisection also. Other symbols like a not and all things it will allow because the not is applied on unary operator. So what is that we try to do in this class is very simple. We are trying to learn about the second version of axiomatic system with some constraints. Like if you remember the yesterday class, we have many rules that can be applied. That rules are addition rule and you can simplification rule. Just you try to remember these rules that we have seen yesterday. Just a minute, I will show them. So if you remember the rules that we have discussed yesterday, like that rules I will just show you just so that you will remember. These are the inference rules that we have studied and we have been discussing about this inference rule for the last two classes. So natural reduction system is a system which will allow all the symbols are not, this is and, implication, by implication, so on and so forth. And it will also allow all these particular rules to be satisfied. So you can apply any of these 9 rules or 7 rules to get the inference. But in this class, what is that we are trying to do is we are trying to have a different version of axiomatic system where we will allow only one symbol, binary symbol, that is an implication is allowed. Other symbols are not allowed. This symbol is allowed. Not is allowed because not will be applied in generally for operators. So this is the only symbol that is allowed, and the symbols that are not allowed is are, and, by implication, and so on and so forth. And the number of rules that it will support is only modest tolerance. Something like you have something called as P, you have something called as P to Q, then you can infer this Q. This is the only inference rule that it will holds good. So if you summarize what exactly I have told is, axiomatic system is a system which will not allow this R and an implication, which will allow only this implication part. This is by bidirectional operator, so by implication or bijection, whatever it may be. So it will allow only this implication part, and only this inference rule is only valid. No other inference rules are valid. This is called as modest ponens. We have seen 8 to 9 rules yesterday and day for yesterday. All these 8 to 9 rules will not be applied here. So only one symbol that is permitted is implication. Only one rule that is given is this. So based on that, you need to apply and try to conclude. Can somebody just tell me what is the output of inference management system? Please unmute yourself and just try to answer this query. Then we'll just proceed. What is the output of inference management system? Yes. What is the output?
True or false?
Yes. Only two things are there. Whether the statements that we have given, you need to validate whether the inference is true or false. So for telling whether the inference is true or false, you need to only use a single operator that is called as an implication. That's what I'm saying. The second version of your axiomatic system will uses only this implication operator. It should not use R, it should not accept, and it should not accept this bijection. It has to only accept this implication. And apart from that, apart from the inference rules that you have studied, I can use only one inference rule, that is modest tolerance. P to Q, P is there. We can get this Q, this is called as modest ponens. We can use only this rule. So if somebody asks me what exactly is the final version of axiomatic system, I have to say axiomatic system is a system which will not allow and or bijection symbols, and it will only allow this inference mechanism. This is modest ponens rules. Only this modest ponens rule is only allowed in this axiomatic system. So whatever the discussions that are done yesterday and day for yesterday is the first version of axiomatic system called as natural reduction system. Natural reduction system is a system which does not have any constraints on the number of symbols and number of rules that is applied. Natural reduction system is a system which does not have any constraints on the number of symbols you use, whether it is a bijection or implication, whatever it may be. So, okay, we'll get back. A natural reduction system is a system where all the symbols are accepted, all the rules are accepted. An axiomatic system is a system where many symbols are rejected, and are, bijection, and all these symbols are rejected, but only inference rule that is accepted is modus ponens, which is very important. Now if you wish to get into the next slide, I need to have something like this, like I need to represent A and A or B, or I need to represent A and B. How can you get this? Just I will write here, this is better. How do you write A or B in the terms of implication? How do you write A and B in the terms of implication? Can somebody just try to have an insight here? And what is, because bisection is not allowed, what is this in the terms of implication? Because implication is allowed. What can I write here? A or B, how can you write in the terms of implication? A implies B, you are writing negation of A or B. This is what it is. So you know this part, because most of the time you have done your discrete mathematics. I have seen that you have done considerably well in the discrete mathematics. So what can be this term in the terms of implication now?
Negation A implies B.
Negation of A implies B. Is this right? This has to be right, and you need to just remember this, because many times we'll be using the same thing. In the same context, how do you write A and B by using this implication part? Just we have to write something on paper, then only you can get. You need to type something or you write something on the paper, then I can do it. So just see, if I write a negation here, is this right or is this wrong? Is this right or wrong?
Right.
See here now, is this right? Is A and B equal to this part? Is that statement is right? This is negation of A. V negation of B. Now what I have written here is right. Just find out whether this is right or wrong. Is this right? See, once you apply this, what will happen is A will be there, N will be there, and you will also get a B. So obviously this has to be right. Can somebody tell me whether somebody can just claim that this statement is wrong? Is this right? See, is my voice is audible?
Sir, screen is not getting updated.
Okay, okay. Now is it getting is it visible? The screen is.
Screen is visible, sir, but it is updating.
Just find out whether the screen is visible or not. Just a minute. I will again share them.
Sir, we are unable to see content on the slides.
Okay.
Only A or B is visible.
Uh, Now can you see the content now?
Yes, sir.
Yes or no? Yes. Okay. Whenever you are not able to see the content, just try to ping me, because I don't know whether I feel that you are seeing the content and just going. So now just tell me whether this equation is right or wrong.
Yes, sir.
Yes or no?
Yes, sir.
Yes. Okay. Still, your voice is also not touching. Maybe this may be right. So why we are thinking about why you are representing this and are and all the things by using implication? Why we need to convert this and ars and bijection into implication part? Can somebody tell me why I am converting this and ars in the terms of implications? I need some response. Can somebody tell me why I am converting this ands and ars into in the terms of implications?
Because
Can you type something now in the chat box, like why we need to convert this into implication? Just we'll see how people are. Just type something in the chat box. Why we are converting this into implication part? Why we are doing this? Yes, I'm very happy that I have a reply. Okay, okay. See, this is the answer. Like what she is telling is right, somebody, but I just felt whether I am connected with the class or not properly. So the only operator that is allowed is implication. So that is the reason we are just converting this R's and unds in the terms of implications. So what is A by implication B? In general, this is what it is. This is and has to be written like this. A bisection B is this by using. This is what the rule is. So the interest is how can you represent bisection in the terms of implication? That is what my target is now. This is what the actual rule is. So see this and see this. If you see both of them, this two are connected by using this AND. So where the first operator is this, the second operator is this. So I can just write this class is very important in the context of your external exam. Most of the time when people try to ask you some question in this inference mechanism, the first question they will ask you is the second version of axiomatic system, because the first version is very flexible, like it will accept all the operators, at the same time it will accept all the rules. So in general they will not ask about natural deduction system. In fact they will ask you about an axiomatic system version 2 where many restrictions are there. So your AI system generally talks about generally try to solve problems in the terms of you have many constraints, how do you solve them to address these constraints. So this second part is very important. So what I said is A and B, you have an answer. The same thing I am representing here, where A is A implication B. The same nomenclature I am using here, and B is also A and B. That is the reason. What is that I have done is just you need to just confirm whether what I am doing is right or wrong. So A is A to B and B is B to A. Whether this statement is right or wrong, somebody has to just tell me.
Yes, sir.
This
It's
is right. Okay. So again, what is my intention is somebody asks you about axiomatic system, you need to tell these symbols are accepted, these symbols are rejected. And I also said only one inference rule is there that most of the people remember. Yesterday we have done this problem. We have only one rule that is applied here, that is this, that is Q. Only one inference rule is valid, that is called as modus ponens. So this is the only rule that can be applied for this inference mechanism, and only one symbol that is accepted is this implication, and this negation will automatically is a default operator that is allowed in every system. So the first part of the class is very important. If you summarize what actually you have discussed, this is what it is. So the operators that are allowed are implication. So these three rules are the rules that I have taken directly from your textbook, are very important. This is how you represent R in the terms of implication. This is how you represent AND in the terms of implication. This is how you represent bijection in the terms of implications. So when you have some question like this, like you have a question like this and you are asked to infer something whether you can get Q or not, then you need to convert this all this into somewhere where you get this implication, then you try to answer, because this is not valid and this is also not valid in your axiomatic search. So you need to also remember the way in which I started the class. Axiomatic system is having two versions. The second version we are discussing now, that is the final version. Whatever we have discussed in the earlier class and in the before that class, two classes we have done, is called as natural deduction system. That is also called as the first version of axiomatic system. Natural deduction system is a system where every operator is allowed and every rule that we have discussed is allowed. We have seen 9 rules, in that we have used 7. So all these 7 or 9 will be accepted in NDS, natural deduction system. But axiomatic system is a bounded system where the scope is very less. in the terms of how do you accept the rules, how do you accept the symbols. This is what it is. So we are just moving ahead. Then when we have only this implication itself is accepted and we wish to convert all these things like this, then how can we proceed? So how can we proceed means we have only, three rules there. Again, I have three rules that I will write here. When you say that I have some statement called as A is a fact, B is a fact, and C is a fact, when you have a fact like this, then your axiomatic system says, I'm writing some new symbol here, and then I'm writing A here. Is now I'm writing some rules. This will show you how your axiomatic system will validate the facts, validate your statements, and try to infer what exactly is happening. When you have ABC statements or ABC symbols, which are, we call it as facts, then this is also a fact. But you need to understand, I have taken A here, I have taken A here, and I have introduced B here. So that is a fact. And if you have something like this, like if I have something, this is a rule that I have written. I write not B, now I will write something called as C. If this is there, then to be implication A to C is also a fact. What I am trying to tell you is the rules that are there in this axiomatic system, where these rules are very important. Whenever people have asked you, you have to write these rules. These rules are very important, and whenever you are attending the class, try to unmute yourself. Okay, so you have a third rule, a very simple rule, negation of A, tend to negation of B. When this is there, then B2, once we do the problem, then we will understand what exactly I am trying to tell you is a fact. So these statements are very important. Whatever I have written, these statements you have to just think, see what is these statements are. So axiomatic system is a system which will allow only the implication, and whenever ABC are statements, then this is also valid. This is true. So when ABC are some statements, this is also true. This I have to write here as this. Okay. When ABC are statement, this is also a fact. So you can, but you need to understand here, when I write A here, I'm writing A here. So in your textbook, it will be something like alpha to beta to A is a fact. Alpha to beta to gamma is there. So you will expand. ABC represents some alpha, beta, gamma in your textbook, but that's what it is. So I write negation of A, negation of B. I have written a reverse here is also a fact. So axiomatic system, you know what exactly is axiomatic system, you know the rules. The inference management system that we have to use here is only one rule you have to use. That rule is modus tollens, that is P is a statement and P implies Q is a statement. What is the inference that you can get here from this is a Q. This is what we have seen. This is called as modus ponens rule. So this is about your axiomatic system. This is what the theory is, but this theory can be understood better when you try to solve some problems. This is what it is. That is the reason, since the textbooks are shared with you, like I have shared almost 3 textbooks, where in every textbook you have some problems. So whatever problems that we do in the class are less and simple, but once you open the textbook you could find simpler problems than what we have done in the classes, but we will also find more difficult problems that were not done in the class. So once you try to understand the concept and try to solve the problems in a different dimension, then you need to have the basics, these basics that we are doing in this class. So again, I'm telling the same story. When axiomatic set or axiomatic system version 2 are asked, so what is that you need to write here is, you need to write that this many number of symbols are not accepted. And is not accepted, or is not accepted, bisection is not accepted. So that is the reason I'm representing the symbols like this. And then you have to write, when ABC are some facts, all these 3 are also facts, or all these 3 can be well formed formulas. And the only inference rule that we can use is this modus ponens, that is P and P implies Q is there, the output is Q. So this basic things you have to remember, and just we'll go to the slide to show how this representation was given in your textbook. This is how the textbook says. Every time the following statements are true, when your alpha is true, beta is true, that's what it is. What is that you need to represent, you need to identify here is, in that text also have written A to B to A. So every time I'm writing, I am taking an alpha here, I'm writing an alpha here. This is a fact, this is a true. So every time when you have something like this, alpha to beta to R, then this is also in a valid statement. You represent this. This is how it is going on. So while you have alpha beta as facts, this is also a fact. I'm just finding where it is, cursor it is. Okay. This alpha to beta, just find out how it is, and this is a reverse of this. And the only inference rule that can be applied is a modus ponens that we have seen. When you have 2 statements called as P implies Q and P, the inference that you get is Q. So you cannot use that other 8 inference rules that we have used in the earlier classes. So by the time we have taken almost 20 to 30 minutes for explaining this, by the time you need to understand 2 things that we have studied as called as a natural reduction system, and we have seen an axiomatic system. Natural reduction system is the first version of axiomatic system, but when some people ask you about what is an axiomatic system, you need to write only the second version, because that is only the version that is applied. NDA system or natural reduction system is a system where every operator is accepted, all the inference rules can be applied. But axiomatic system is a system where only implication is accepted, and in particularly you should not use or, you should not use and, you should not use by implication. Only one rule that can be applied out of 9 is modus ponens. Again we are doing the same thing, but it's very important. But what is the strength, or on what basis your axiomatic system goes is based on these 4 rules, 3 rules and 1 inference. So when people try to ask you what exactly is axiomatic system, this you have to write. Then this is a very important observation. Then they will ask you this type of question. Just see here whether the inference that was given here is valid or not. Just tell me by seeing whether this is valid. I will just take not more time. Okay, C to A and A to B. C to B is valid inference. Yes or no?
Yes, sir.
Yes, what you said is right. But see, the interesting thing here is when we know C to B is a valid, but how can we answer this query using what rules we have? How many rules I have is I have 3 rules, and how many inference equations I have is only one. So the next part of the class, just I will take 5 to 6 minutes to solve this problem and stop. Then we'll solve the other problems later. Later means tomorrow we'll do it. So very simple question that was given here. Very simple, but how can the axiomatic system will be used to answer this query? So you said the answer is right, that it is valid. So if you remember the rules that I said, this is a valid rule. When A, B, C are some facts are there, then this is to be a fact. At this moment, I just have the first step as like this. I will take A to B as alpha. Just I'm using this same nomenclature that was used in the textbook now. This is what the textbook says. So if I take A to B as alpha, where alpha is something that was given in the textbook like this. So what can be true is, what is alpha is A to B. Yes. What can I take beta? What can I take here? Can I take C?
Yes, sir.
Yes. You need to understand, or you need to say whether what I have highlighted is right or wrong. Is this true? I have written the second statement is a fact. Is it right or wrong?
Yes, sir. Right.
Yes. Yes. So what was given in our example is, you have something called as A to B was given as a fact. What is the inference from 2 to 3? What is the inference that you can get from this 2 to 3?
C implies
Just
A
I will write
implies
this so that you will understand. What is the inference?
C implies A implies.
Yes.
C implies alpha.
What you said is right. This whole thing will come as an inference, because we can use only one rule that is called as modus ponens. Modus ponens says this is P, this is P to Q, I will get Q. So this is P, this is P, this is Q, I got this Q. So now just tell me, when I have a statement like this, then what is true is, just I will apply this second rule now. Just I am copying the second rule from this. It will take some time to understand, but it's very easy. And once you solve some problems, 3 to 4 problems, you can understand this structure. I'm just using the second rule that I have written here. This rule says I'm just copying this part here. This, if something is like this, so then what is valid is this is valid, that it is telling like this, C to B. There is no need that we have to write this. Okay. Now just tell me whether this statement is right or wrong.
Yes, sir.
I can write a brace here. Slowly you will understand. So this statement is as per the rule that 2 is right. So if the fifth statement is a valid statement, if fifth statement is a valid statement, what is the inference from 4 comma 5?
C implies B, sir.
This is P, this is P. What the inference is? This part is the inference. Is it right? This part itself is the inference. So for inference from 4 to 5 is something like this. This is what the inference is. So we were given that C to A is a fact. We can take that C to A is a fact. This we can call it as seventh step. C to A is a fact. What is the inference from? 6 comma 7
C to B, sir.
is C to
C to
B.
B, sir.
Implies
Ooh, B. So we have to just prove whether C to B is there. C to B is already there. But you need to understand, when there is a restriction on the number of symbols that we can process, when there is a restriction on the number of rules that we can apply, then this proving is very difficult. When you wish to construct a system with constraints, then it's very difficult. Without constraints it's very easy, and it's very easy to infer also. So we have many examples that we have to deal with. So because I have come with almost 3 or 4 examples in the slides, all this we have to do. So this will take up tomorrow, but this a class is very important, because this class is very important. The reason is axiomatic search is a world search. Without that, most of the people will not ask you, like in a external exam, every time this axiomatic search will be there. Sometimes they will ask you about both versions of axiomatic search. Sometimes, mostly they will ask you about the second version of your axiomatic search. First version of your axiomatic search, I said it is a NDS, we call it as a natural direction system. We have seen this natural direction system in 2 classes, yesterday and day before yesterday. This class, the entire concentration will be an axiomatic search. So we have solved a single problem, but it will take some time to understand how I am applying and how I am getting this. So we will solve more problems tomorrow. Then most probably tomorrow we will conclude this axiomatic search, and then we will go to semantic search. So this is what about this class is, and I have taken exactly 40 minutes again, because we are asked to take only that much amount. And again, yesterday we have a good number. Today the number of students are less again, for various reasons, I don't know. So I have received almost